Hello and welcome to a new video on IGCSE mathematics. In this video, we shall be discussing polygons and we shall be dealing with advanced problems. 5 angles of a hexagon are each 115 degrees. Calculate the size of the sixth angle. So a hexagon is a polygon with 6 sides and 6 angles, of course. So in order to calculate the sixth angle, we first need to get the sum of angles in a hexagon. And this is obtained using the rule n minus 2 times 180. Now n here is 6. So we have to multiply 6 minus 2, which is 4, by 180. And that gives us 720. So this is the sum of all 6 angles. And we are given that 5 of them are each 115. So what we need to do now is simply to add them up together. So we have 115 plus 115, 5 times like this. And then the sixth angle is x, and the sum of these angles is 720. Of course, these 5 angles can be written as 115 multiplied by 5 plus x equals 720. So let's figure out 115 times 5 on the calculator. You get 575. So 575 plus x equals 720. Finally, you subtract 575 from 720. So 720 minus 575. X equals 720 minus 575. And using your calculator, you get 145. And that is the size of the sixth angle. In a regular polygon, the interior angle is 11 times the exterior angle. Work out the number of sides of this polygon and then find the sum of the interior angles of this polygon. So first of all, let's use this piece of information here and recall the rule that one interior angle plus one exterior angle equals 180. So if the interior angle is 11 times the exterior, we can call this x. So the exterior angle here would be x, and the interior angle would be 11x. So 11x plus x equals 180. Therefore, 12x equals 180. Therefore, x equals 180 divided by 12. And that gives us 15. So one exterior angle is 15. To get the number of sides, we simply divide 360 by x, which is 15. So 360 divided by 15 gives us 24. And therefore, the number of sides of the polygon is 24. Now, to get the sum of interior angles, all you have to do is apply the rule. You just do 24 minus 2 times 180. And that gives us 22 times 180. And you just use your calculator. And you get 3,960. Now let's check the marking scheme. So 24 is the correct answer for I. 3,960 is the correct answer for double I. The diagram shows a regular octagon joined to an equilateral triangle. Work out the value of x. So here they didn't give you any information except that you have an octagon and an equilateral triangle. These are both regular shapes, so all the sides are equal. So you have here 3 sides. Of course, you should know by heart that if you have an equilateral triangle, these angles are all 60. But I can prove it to you as well using the rule of polygons. So if you remember, the rule for one interior angle is n minus 2 times 180 over n. So for an equilateral triangle, you just write 3 minus 2 because a triangle has 3 sides. So 3 minus 2 times 180 over 3. And that gives you 60. I'm going to apply the same rule again for the octagon. Of course, you can, if you don't know how many sides there are in an octagon, you can just count the sides. There are 8 sides in an octagon. An octagon, octa means 8, just like an octopus has 8 legs. So anyway, we plug in 8 for n. So we have 8 minus 2 times 180 divided by 8. And that gives us one interior angle in an octagon. So you have 6 times 180 over 8. And you can get this as 135. So the angle inside the octagon is 135. Finally, you figure out that this angle, which is 60, plus this angle, which is 135, plus x, these must form 360 degrees because all three angles around the point, or any number of angles forming a complete point, would sum up to 360. So therefore, we just add up the three angles. So 60 plus x plus 135 equals 360. Therefore, x plus 195 equals 360. So x equals 165. And 165 is the correct answer. The diagram shows a regular pentagon. AB is a line of symmetry. Work out the value of D. So a regular pentagon is a polygon with 5 equal sides. We can get one interior angle using the rule n minus 2 times 180 over n. Therefore, the n here is 5. So we have 3 times 180 over 5. And this will give us 108. So one interior angle in the polygon is basically 108. So therefore, D is basically half of one interior angle. So D is half times 108, and that is equal to 54. 54 is the correct answer here. The diagram shows part of a regular polygon. The exterior angle is x, the interior angle is 29x. Work out the number of sides of this polygon. So it might look confusing or weird, but it's really not. You should just recall that one exterior angle plus one interior angle, that gives you 180. And then 29x is the interior and x is the exterior. And these give you 180. So 30x equals 180. Divide by 30 on both sides. You get x equals 180 over 30. And that is equal to 6. So now that we have x, which is the exterior angle, we can just use n equals 360 over x. So 360 divided by 6, and that gives us 60 sides. The diagram shows an octagon. All of the sides are the same length. 4 of the interior angles are each 32. The other 4 interior angles are equal. Find the value of x. Of course, this is not a very direct question, requires some thinking, but no problem. In order to get the angles in the octagon, we need to figure out what the given information is. So 4 of the interior angles are 32, and the 4 other interior angles are equal. So let's call these y, for example. Each interior angle is y. So the sum of interior angles in an octagon would be n minus 2 multiplied by 180. And n here is 8 because an octagon has 8 sides. So you have n, or 8 minus 2 times 180. 6 times 180 on the calculator gives us 1080. So this is the sum of all angles in the polygon. Now, what are the angles? So we have 4 angles that are each 32. And the other 4 angles are each equal to an unknown, which we don't know, which is y. So 4 times y. And the sum of all 8 angles is 1080. So now we have an equation in y, and we can solve to find y. So 4 times 32, this gives us 128, plus 4 times y, which is 4y. And this is equal 1080. So therefore, we subtract 1080 minus 128, and we get 4y equals 952. Finally, we divide by 4. So 952 divided by 4, that gives us 238. So therefore, y equals 238. Of course, let's put this on the diagram itself. What are the 4 equal angles here? The 4 equal angles, of course, are the tips. So this is 32, this is 32, and this is 32. And then the other 4 angles, which are each equal 238, are these red angles here. So we want to find the value of x. We should just understand that the 238 plus x forms a complete circle. So 238 plus x equals 360. So therefore, x is simply 360 minus 238. This gives us 122, which is the final value of x. So 122 here is the correct answer. The angles of a quadrilateral are x plus 5, 2x minus 25, and x plus 10. Find the value of x. We said before that the quadrilateral has a sum of angles equal to 360. So we form an equation, x plus 5 plus 2x minus 25 plus x plus 10, all equals 360. And then we simplify. So we have x and x, this is 2x. Now this is 4x. Now we have 5x. So this is 5x. And then 5 minus 25 would be negative 20. Plus 10, that would be negative 10. So 5x minus 10 equals 360. So therefore, excuse me, I made a slash by mistake. So therefore, 5x equals 370. We take the 10 to the other side, we add it to the 360. So therefore, x equals 74. Now, in question C, we are told a regular polygon has 72 sides. Find the size of an interior angle. So n equals 72. We should know that 360 over n gives us x. So x equals 360 over 72. And that's equal to 5. X is one exterior angle. So you should know that one exterior angle is related to n by the equation x equals 360 over n, or n equals 360 over x. It's the same thing. So anyway, now that we have the exterior angle, we should remember the rule that one exterior angle plus one interior angle always gives us 180. So therefore, in order to get the interior angle, we just plug in 5 here. So 5 plus something gives us 180. So this something must be 180 minus 5, which is 175. So therefore, one interior angle, let me write this here more clearly, equals 180 minus 5, which is 175. So 74 is the correct answer for B, and 175 is the correct answer for C. Let's move on. In the hexagon ABCDEF, AB is parallel to ED, AF is parallel to CD, angle ABC equals 90, angle CDE equals 140, and angle DEF equals 120. Calculate angle EFA. So in order to calculate angle EFA, we need to figure out what the angles are. We need to figure out the relationships between the angles. So first of all, this is a hexagon. And we have a couple of unknown angles here. So I like to use letters to denote the unknown angles. So you have A here, for example, B, C, and D. And we can even split the 140 into E and F just to make sure that we have enough information to solve the problem. We are looking for angle EFA. So basically, we're looking for the letter A small. That's the letter that we need to find in this case. And we can construct many different equations until we find the correct answer. So for example, let's take the shape on the left. Let's take this trapezium here. This is a quadrilateral. So since it's a quadrilateral, we should know that the sum of angles here must be 360. So we can construct the first equation, A plus B plus F plus 120 equals 360. And then we can simplify, so we can just write A plus B plus F equals, and then we take this to the other side, so 360 minus 120 gives us 240. So this is the first equation that we have. Next, we want to use the parallel lines to construct other equations. So first of all, let's just realize here that we have parallel lines here and there, and these form a Z shape like this. So therefore, one equation that we can write is that F equals to C because of the interior angles, alternating interior angles. Furthermore, we also have DC parallel to AF, and therefore angle B equals angle E as well. So we have another equation here, B equals to E, again by alternating interior angles. We also have, of course, the very obvious equation that F plus E equals 140 because we split the 140 into F and E. So now we have F plus E equals 140. Finally, we have the polygon on the right. So let's just color that. The sum of angles in this yellow polygon or yellow quadrilateral must be 360 because four sides have a sum of 360 in a polygon. If a polygon has four sides, then the sum of its angles is 360, I mean. So E plus C plus 90. Of course, this square here means 90. And plus D. All of this equals 360. So we have a lot of equations here. We have almost 6 equations, and we have 6 letters to figure out. So this might work. Let's just try to remove letters from the equations. How do we remove letters? So first of all, let's get rid of the F. So any F we see, we just replace it with C, since F equals C. I'm just going to cross this equation out, and then any f I see, I'm just going to put c here instead. So this is c, and this is c, and this is c. And then we also have b equals to e. So we can cross out this equation here, and we can replace any e with b. So any e that we see, or any b with e, doesn't really matter. So let's just cross out the b's and put e's instead. So this would be e, and this would be e as well. And then that's it for now. Next, we have c plus e equals 140. So this is nice because if we look at this here, c plus e equals 140, you can replace the c, for example, with 140 minus e. So let's try to do that. So let's say that c here is equal to 140 minus e. And then let's cross this equation out, and any c that we see, we replace it with 140 minus e. So here we have 140 minus e. And up there as well, we have 140 minus e. And here as well, we have 140 minus e. So you begin to see how it all works out, because you have e and minus e in each equation, and these will just cancel out. So we can actually just work on the first equation, because this will be quite simple and it will cancel out. So e will cancel out the negative e, and we get a plus 140 plus 120 equals 360. So a plus 260 gives us 360. So a equals 100, because we subtract, of course. And the final answer for a is 100. And we don't even need to look at the equation below in red. That doesn't even help in getting the answer. We could have used it if they were asking for the letter D, for example. We could have used the same logic, and we could have obtained D as well. So anyway, for question A equals 100 is the correct answer, and we can move on to question D. So in question D, we are told a regular polygon has n sides. Each exterior angle is equal to n over 10 degrees. Find the value of n. So of course, we know that the exterior angle x is related to n using the equation 360 over n. And we are told in this particular question that the exterior angle is equal to n over 10. So instead of x, I can write n over 10. And then we can just cross multiply. And we can say that n squared equals 360 multiplied by 10. So therefore, n squared equals 3,600. So therefore, n equals to 60, which is the square root of 3,600. Now that we have n, we want the size of an interior angle of this polygon. So let's first get the exterior angle. X equals 360 over n. Excuse me, I'm very sorry. N is 60 here, not 360. This is a mistake. We got n as 60. So 360 over 60. And this gives us 6. So one exterior angle is equal to 6. Therefore, one interior angle is equal to 180 minus 6. And that gives us 174. This is the measure of one interior angle in this polygon. And 174 is correct, and 60 is correct as well. So the final answers are matching those in the marking scheme. So we are fine with this problem. The diagram shows a triangle and a quadrilateral. All angles are in degrees. For the triangle, show that 3a plus 5b equals 170. Now, this is quite simple. You should know that the sum of angles in a triangle is 180 degrees. So therefore, we just add them up. We have 3b plus 10 plus a plus 2b plus 2a. All of this is equal to 180. Let's simplify. So we have 3b plus 2b. Let's cancel these out. 3b and 2b, that gives us 5b. A and 2a gives us 3a. And let's take the 10 to the other side. So this is 180 minus 10, which is 170 degrees. For the quadrilateral, show that 9a plus 7b equals 310. So again, you should know that the sum of angles in a quadrilateral equals 360 degrees. You can just add these up. You have 8a plus 3a plus 2b plus b plus 50 plus 4b minus 2a. And this is all equal to 360. Let me write it on the right. Excuse me. And then we collect the like terms. So we have 8a plus 3a, that's 11a. 11a minus 2a, that gives us 9a. And then for the b's, we have 2b plus b, that's 3b, plus 4b, that gives us 7b, plus 50 equals 360. Therefore, if we subtract 50, we get 9a plus 7b equals 310. So the second equation is proved. Next, we are required to solve these simultaneous equations and show all of our working. I'm going to erase the writing on the screen since we have the final answers already given in I and double I. So we derived these equations. We proved that these equations are correct. In triple I, we are required to solve them together simultaneously. So we have 3a plus 5b equals 170. We have 9a plus 7b equals 310. We can multiply the first equation by 3. And then this becomes 9a plus 15b equals 510. And we no longer need this equation here. We will solve these two equations together by elimination. So we'll just subtract. So 9a minus 9a gives us 0. 15b minus 7b gives us 8b. 510 minus 310 gives us 200. So 0 plus 8b equals 200. Therefore, b equals 200 over 8. And that gives us 25. And then for a, we get 310. So of course, I can use whichever equation. I decided to use this equation to get a. So I'm just going to put b as 25. Let me rewrite it. It's going to be 9a plus 7b, which is 7 times 25, equals 310. 7 times 25 is 175. And then 310 minus 175 gives us 135. So 9a equals 135. And then you divide 135 by 9. You get 15. So a equals 15. So therefore, a equals 15. These are the final answers for question triple I. Now that we have A and B, we are required to find the size of the smallest angle in the triangle. So how do we figure out which one is the smallest? There are two ways. The simple way or the systematic way is to just plug in all the A and B in all the angles, and you find the measure of each angle and you pick the smallest. Or by eye, you can figure out that since this side is the smallest, then this angle will be the smallest as well. Anyway, let's just try and see. So 2 times A is 2 times 15. So this angle here is 30. And then here we have 3B plus 10. So 3 times 25 is 75 plus 10, that gives us 85. Finally, in this angle, we have A plus 2B. So 15 plus 2 times 25, which is 50. So that gives us 65. So therefore, of course, the size of the smallest angle is definitely 30. And we can see that for AIII, 15 and 25 are the correct answers. And for AIV, 30 is the correct answer. So we seem to be on the right track here. In the final question in this video, we are first required to show that each interior angle of a regular pentagon is 108 degrees. So in order to find one interior angle, let's first get one exterior angle. So x equals 180. Excuse me, I'm very sorry. X equals 180. X equals 360 divided by n. This is the rule that we should be using. So let's write that down. X equals 360 over n. Here, this is a pentagon. So a pentagon has 5 sides. So this is equal to 5. 360 divided by 5 is 72. So one exterior angle is 72. So one interior angle is 180 minus 72. And this is equal to 108. And we have proved that one interior angle in a pentagon is equal to 108 degrees. In question B, the diagram shows a regular pentagon ABCDE. The vertices lie on a circle of radius 12. M is the midpoint of BC. Find BM. In order to find BM, this is a bit advanced, but we can do it. So we know that M here is the midpoint of BC. So we might need to find the length of BC by looking at this triangle here. And in general, whenever you have a pentagon or a polygon of any size, it would be a good idea to split it into triangles as I'm doing here, and to understand that these angles are all equal to each other. Since we have 5 sides, so we're going to have 5 angles as well. And like we said here, if we divide 360 by 5, we can get the value of x. So one angle here is 72. How would that help us? That would help us to get the length of a side of one of these triangles. So for example, if we take triangle BOC out, since we have BOC here like this, we know now that this angle is 72. We know that the radius here is 12 and the radius here is 12. So we can use the cosine rule to get the size of BC. So how do we get BC? BC equals, or BC squared equals 12 squared plus 12 squared minus 2 times 12 times 12 times cosine of 72. So let's try to figure this out. Remember that the term that comes after the negative should all be put in one big bracket so that the calculator does not miscalculate. So of course, 12 squared is 144. I like to calculate each part separately. 144 plus 144 minus, and then I'm going to calculate the stuff inside the bracket. 2 times 12 times 12 times cosine 72. I got 88.99, so roughly 89. And this is equal to BC squared. So BC squared equals 144 plus 144 minus 89. And that gives us 199. So we can get the square root of 199. Therefore, BC equals 14.1. Therefore, BM equals half of BC, and that's 7.05. Let's check the marking scheme. So BI gives us 7.05, excuse me, as we obtained. Now let's resume. So we have BM as 7.05. We are told that OMX and ABX are straight lines. Find BX and calculate the area of triangle AOX. So we need to figure out how to find the length of BX and how to calculate the area of triangle AOX. So let's color the triangle first. And this is interesting because the angle AOX is kind of weird because we should know that AOB is 72. We already got that in the previous problem. Each angle is 72. And then BOC as a whole, this angle as a whole is also 72. So this part of the angle here, it's half of the 72. So this part would be just 36. Because OM splits it into two equal parts. So we should know that for angle AOB, for angle AOX, we have the sum of 72 and 36. So let's draw this outside to gain a better understanding. This is AOX. And this angle here is 72 plus 36. So 72 plus 36 is 108. This is the size of this angle here. Furthermore, we know that OA is a radius, so this here is 12. We can also get the measure of angle OAX. So let's call this Y, for example. And let me show you how you can get this very simply from the diagram. Here, if this is Y, then this is also Y, because this is an isosceles triangle since it has two equal radii in the circle. So if we want to get Y here, all we would have to do is Y equals 180 minus 72 divided by 2. This is because Y plus 72 equals 180, sum of angles in a triangle. So 2Y plus 72 equals 180, and therefore you get Y equals 180 minus 72 over 2. So Y equals to 54. So now that we have Y as 54, we can also get the third angle in the triangle. So if this is 54 here, we can get the third angle in the triangle by saying 108 plus 54 is 162. So 180 plus 54 plus this angle, which is Z, equals, this is 108 plus 54 plus Z equals 180. So 108 plus 54 is 162. So 162 plus Z equals 180. So therefore, Z equals 180 minus 162, which gives us 18. So the angle in this triangle here, the third angle, is equal to 18. And now that we have the three angles, we can definitely get the area of AOX. I'm going to show you how, but we also want to figure out how to get BX. So in order to get BX, let's first get side AX. So how would we be able to get side AX? Using the sine rule, of course. So if this is 108, let's call this side, for example, M. We can say that M over sine 108 equals 12 over sine 18. And then let's take this to the other side, to the numerator. So it becomes 12 sine 108 over sine 18. So let's try to calculate this. So 12 sine 108 equals something, and then you divide that by sine 18. and you get 36.9. So therefore, M equals 36.9. So how does that help us? How does M help us? Well, it helps us in two different ways. It will help us solve both A and B. So let's just write here 36.9. We are first required to find Bx. So let's go back to the diagram. What is Bx in the diagram? Bx is this green part here. And this green part added to this yellow part here gives us the total of Ax. And we already know the total of Ax, which is 36.9. So now we have an equation that says AB plus Bx equals 36.9. So are we able to get AB? Of course, we're able to get AB because we already got BC in the previous question. In fact, this is how we got BM, since we said here that BM is half BC. We got BC and then we got BM. So let me just multiply the answer by 2, and that just gives us BC automatically. So BC is 14.1, 7.05 times 2. And that gives us 14.1. And since the pentagon is regular, all the sides of the pentagon have the same length. So we have here 14.1, 14.1, 14.1, 14.1. Each side is going to equal 14.1. So therefore, AB itself equals 14.1 as well. And now we can get Bx as 36.9 minus 14.1. And that will equal 22.8. So that's the size of Bx. And then to get the area of triangle AOX, we simply apply the area rule. We have a side and a side and an angle between them. So the area would be half AB sine theta, which is basically half times 12 times 36.9 times sine 54. And that would give us I'm writing it on the calculator, 0.5 times 12 times 36.9 times sine 54. That would give us 179.1. So just 179 would work. And that brings us to the end of our problem. Let's check the marking scheme. So 22.8 is correct, and 179 is correct as well. Let's check. There you are. 22.8 and 179. So this brings us to the end of our video. I hope this has been beneficial. Thank you for watching.